And what it's doing, it's separating the range of the data set, of a univariate data set. It's putting the entire range into these discrete intervals. Each interval is a bin, and it's showing you the counts, the number of observations that fall in that range. So your view of the shape is going to be affected by how many bins you have. And the default apparently is 9. Looks like 9. So you can change that with the breaks argument. If I say histogram Nile breaks 15, that will create 15 bins. And indeed, it's giving us a different picture, a different view. This looks a little different. And note you can toggle forward and backwards in RStudio. It creates, you can't show two graphs together unless you can jury rig it, but what it does do, it creates like a scroll, a memory scroll, so you can always go back to previous plots. When we increase the bins, we do get a different view of the distribution. It becomes more continuous. Looks more like a continuous function. Okay, so there's other things we can do with the graphics. Very good graphics in R, particularly lattice. Lattice is good for multivariate graphics, and we'll do a lot of that. Okay, let's talk a little bit about the different data structures. I've gone on and on. This might be a good place for a break, 15-minute break. Anybody have any questions or want to say anything? I don't mean to just talk endlessly, but I will if you don't stop me. Any questions? Let's take a 15-minute break here. And I will start the timer. There's a built-in timer. Just before we get back into the scripts, so I don't forget at the end of the class, let me just show you a couple of things. Here's the material for today. It's pretty self-explanatory. In the first day, normally I give out some documentation that I think is helpful. It's not meant just to fill up this folder. The R documentation's really, it's good in this way. It's very concise. It's also written by the people on the core development team. It's comes out with a new version with each release twice a year, so it's current. Particularly the intro, if you're new to R, the intro, it's not, I wouldn't even call it a manual. It's not a manual. It's only about 100 pages long. But they know what to say. They know what you ought to be exposed to quickly. So this one particularly, you can go through the first 30 or 40 pages, and it's like all of their documentation, there's a lot of examples. They have script, and so you can interactively run the script as you're reading the text. And again, I can't say anything but give it a lot of praise. They've been doing this a long time, and they know what to tell you first. And it's short. It's not just something you have to wade through for hour after hour. So you have that. The R language is about programming. It's about the programming language itself. So I thought that one was appropriate for this course. The ext extensions, this is for writing. The other one is for, this is the unique things about the R language, which is important to programming. And we'll make frequent reference to this, I tell you. And then this is about packages and extensions. Now, what else do we have here? There's some slides, and I don't think we'll get to the basic data structures today. We'll pick up on that quickly. The primitive data types, we'll pick up on that first thing next week. But there is an exercise, and I just want to show it to you before I forget. It's easier than it looks. I ask you to write a function that can do this, that can create compare two samples to see if their means are significantly different from each other. So it's just like a student's t-test, but it uses pooled variance. And when you start seeing Greek letters, my first reaction is my eyes kind of glaze over and I go, no, I can't do this. This is really deceptively simple to program in a function, and we'll show you how to create functions today. And in fact, I give you the steps down here. All you have to do, here's our header. This is the header for our function. All you have to do is fill in the body with statements, one line after another, that accomplish these things, these tasks. And if you can do these, you've created the function. So it's much easier than you would think, even though it looks scary. And likely we'll extend this in exercises in subsequent days. Even if you give a try at this and it's too hard or you don't have time, I will try and distribute the answer next week so that you can continue. You can pick it up and then try and do the next part if you care to. But I'll try to give you at least one or two exercises every week so you have something to chew on. And so this is the one to start with. Okay, so let's go back to our... So we're looking at interactive mode, and we're looking at the data types. Now, scalars, I already mentioned, really don't exist. Here's a scalar. We assign the numeric 8 to x, and we see 8 up here. But x is still a vector. Now, vector is a sequence of elements that must be the same primitive type. They don't have to be numbers. They could be characters or strings. The type is a string. Sometimes it's called text, but it's really a string data type. If you have a string, if you have a character and a vector, they must all be characters. You can't mix them. Okay, so here we create a vector. This is numeric again, and we look at it. So it's this vector 5, 12, 13. Length is a reserve function that tells you how many elements there are. So it returns the value of 3. Mode returns its primitive data type, which is numeric. Here we create a variable of string data type. The string is ABC. We can execute, or as they say in R, operate the length function on a string vector. So what's the length? It's only one element. It's the element that is the string ABC. It's not 3 elements. If we say what's the mode is character. Let's create a second one. Here we're combining, using the combine operator, combine these two elements. So we put that into Z. Take a look at Z. Z is a vector of 2 elements. And Z has a length. The length is 2. Z has a mode. The mode is character. Again, vectors have to be the same type. If you try to mix a vector, what happens if we try to mix a vector? Let's say W, and the first element will be the character B, and the second element will be the number 2. Let's see what happens when I do this. It gives me an error. It won't do it. Now, often what it will do is it will coerce them. It will force one to be the same type as the other. For example, if I do this, if I say W is this, and then I say Y is this, and then I say Z, except you know what? The reason why it gave me the error is because you need to use the C. So we'll create a vector W, we'll create a vector Y, and then we'll create a vector Z that will be the combine of W. So let's do this. So here's W. Take a look at W. Here's Y. Take a look at Y. Now I try and create a vector Z, which is the combine of W and Y. What happens? It works. I don't get an error. Take a look at it. It has coerced, it has changed the numeric to a character. It can't change the character to numeric. It makes no sense to try and make a B a number. It can't do it. So it does, instead, it does what it can do, which is change the numbers to characters, because a vector must be all of the same type. If we run length on it, that works. It's got 4 elements. If we run mode, that works. It's character. So R in the background, and sometimes this is your friend and sometimes it's not, will try and fix your mistakes and coerce them into something meaningful that's consistent with the syntax rules. Okay, now here's a well-kept secret about R. R has excellent text manipulation capabilities. It's not regarded in that way. It's regarded as the premier statistical programming language, but in fact it's really, really good at dealing with text mining or normal expressions or any sort of text-based searches. For example, we have these functions paste. There's a number of functions, string manipulation functions. Paste will take whatever arguments you give it and we'll try and combine them all into one string. So if we take these 3 elements, we try and paste them together, and then we look at what we get out of it, we get 1 element, and it's simply put them together into 1 element, but it separated them by 1 character. Note up here in my workspace, it's not too bad, but what will happen as you do this is your workspace will accumulate junk, and you need to clean it out every now and then, especially when you start writing functions. Okay, string split is a text manipulation. It will by default, in this case it will, so here's U, right? U is our vector ABC blank DE blank F. String split will operate against U and will try and separate this into 3 elements separated by these spaces. But string split has another characteristic that's very important. Let's look at the result. String split returns a list. It returns a list. So look at when we express what object, the statement, the return from the string split function, note it looks funny. We get this double subscript. Lists are data elements or lists are structures that consist of components. And list is very versatile. List is probably your most useful data structure. Each component can be any different data type of different length and different types. Lists are heterogeneous data structures, very good for collecting the returns of very complicated functions and putting them in one object. As we'll see, lists are very useful. We'll come back to lists later. Okay, so let's go on and finish our whirlwind tour of some of these structures. A matrix is another important data structure. So we've looked at vectors. We've looked at lists very briefly. A matrix is just simply a two-dimensional array. It's a matrix in math. That's what it is. It's a two-dimensional array, columns and rows, where the columns and rows are of the same length. Not square, but all the columns are of the same length, all the rows are of the same length. Classically, it is numeric. but it doesn't have to be. Most of the books on R will tell you that a matrix in R must be numeric, but that's not strictly true. You can't